probably heard of Maxwell's equations. They're these four just beautiful, elegant lines of math that run pretty much everything in our modern world, from the light hitting your eyes to the smartphone in your pocket. They're the absolute bedrock of electromagnetism. But what if they're not just some rules we stumbled upon? You know, for the longest time, we've sort of treated the laws of physics like they were handed down from the heavens, rules that we discover, we test, and we use to build stuff. But thinking that way leaves this giant, nagging question just hanging there. What if we've been looking at it all wrong? What if these laws aren't arbitrary at all? What if they're actually the fundamental, structural requirements for a universe that can even exist, the only pattern that doesn't just instantly collapse into nothing? Well, that brings us to this really radical framework from a fascinating paper, The Theory of Infinity, or TOI. It proposes that our reality is like a stable structure, a knot that has crystallized out of this, infinite ocean of possibilities. And if that's true, then the laws of Felix aren't rules for the knot. They're the very rules that define the knot and keep it from unraveling. So how could we possibly check an idea that big? Well, the theory gives us a path. It lays out a 7-stage ontological ladder, a way to build a stable reality from absolute scratch. So let's do it. Let's climb that ladder together and see if we can actually derive all of Maxwell's equations, one rung at a time.
All right, here's our roadmap for the climb. We're going to start with really basic ideas like totality and balance, and work our way all the way up to these grand concepts of form and finally, unity. The cool part is that each of these stages represents a core requirement for stability, and as you're about to see, each one maps perfectly onto a piece of electromagnetic theory.
Okay, so we're starting at the bottom, at the very foundation of the ladder, with stages sigma and b. These are the stages that set up the basic, static rules of the entire system. Think of them like the fundamental accounting principles that the universe has to follow. So here we are. The first two principles, totality and balance. This is the absolute bedrock. Everything else is going to be built on top of this. And what's just incredible is how these abstract ideas immediately give us our first two laws of physics. So stage sigma, totality, is basically a global audit. It just says that for any little bubble of space you can imagine, the total electric field flowing out has to perfectly match the electric charge that's inside. You can't get something for nothing. And boom, that's Gauss's law for electricity. Then you have stage B, balance, which demands local closure, no loose ends. And that gives us Gauss's law for magnetism, which is the reason magnetic field lines always have to form these perfect, unbroken loops. Okay, so we have the static rules in place, but nothing's happening yet. A stable universe needs an engine, right? So as we move up the ladder, the next two stages are going to bring in the dynamics, the interlocking gears that finally set everything into motion. We're now climbing up to induction and emergence. This is the real heart of the system, where things finally start to interact and evolve. This is where it gets good. And here it is. This is the aha moment. Just look at this table. Stage I, induction, gives us Faraday's law. If you have a changing magnetic field, it induces an electric field. Then stage E, emergence, gives us the Ampere-Maxwell law, and this is what completes the cycle. A changing electric field creates a magnetic field. Do you see that beautiful symmetry? It's a perfect self-sustaining feedback loop. And the crazy thing is, this cycle wasn't actually complete in the physics books until Maxwell himself added this one little term, called the displacement current. That was the final piece of the puzzle. It's what allows electric and magnetic fields to create each other in this endless, self-sustaining dance, which, by the way, is what we call light. From the toy perspective, this wasn't some lucky guess by Maxwell. It was an absolute logical requirement for the system to even be stable. So our system is now alive and dynamic. But what keeps it consistent? The next couple of stages on the ladder are what define its unbreakable blueprint, the properties that give our knot a consistent, reliable identity over time. So let's keep climbing. We're now at stages K and N. This is where we get into the really deep stuff, defining the knot's fundamental form and the numbers that actually characterize it. Stage K is all about the knot itself, its unchanging form. Now, this maps to a pretty deep concept in physics called gauge invariants, and the paper puts it perfectly. It says it's like having knots that can be retied in different ways, but still yield the same knot shape. What that means is, the math we use to describe the field can look different, but the physical reality you can actually go out and measure, the forces, stays exactly the same. The knot is the knot. Okay, so next up is stage N, for natural. And this gives our knot a permanent ID tag, A fingerprint. Because the whole system has to be stable, certain things must be conserved. They have to be constant, countable qualities. Things you recognize, like electric charge, energy, momentum. This is amazing because it suggests that conservation laws aren't just some random quirk of our universe. They are the direct signature of a stable underlying structure. We've almost made it. We're at the final stage of our climb. And here, at the very summit of the ladder, the deepest and most profound symmetry of all of electromagnetism is about to be revealed. Here we are, the summit, stage omega. This is the point of absolute self-consistency, the point of unity. At this final stage, all the pieces we've been building click into place. The entire structure, built from the ground up, now shows us its true ultimate nature. And that ultimate nature is this. The labels we started this whole journey with, electric and magnetic, they're not actually fundamental. Here at the top, they just dissolve into a single, unified thing. This amazing property is called electromagnetic duality. What it means is that in empty space, where there are no charges, you can literally swap the electric and magnetic fields everywhere in Maxwell's equations, and the laws still work perfectly. It means they're just two sides of the same coin, two different ways of looking at one fundamental thing, the electromagnetic field. This is the ultimate unity that stage omega promised us. So, we climbed the ladder. We made it to the top. What's the big takeaway here? Well, it's not just about Maxwell's equations. It's about a completely new way of looking at physical law itself. Here's the core idea. Maybe, just maybe, physical laws like Maxwell's equations aren't some random set of rules that our universe just happens to follow. Instead, maybe they are the logical, inevitable requirements for any reality that can hold itself together and not fall apart. They're not just descriptions. They are the blueprint for stability itself. And that leaves us with this final, absolutely tantalizing question. If electromagnetism is this perfectly self-consistent knot, tied from the fabric of infinity, what about the other forces? What about gravity, or the weirdness of quantum mechanics? What other parts of our universe are not arbitrary facts we just have to accept, but are the necessary, beautiful threads holding together the grand, intricate knot of reality itself?